Hey guys, welcome. We're doing solve by factoring practice this time around, that ZPP, the zero product property. Let's hop right to it. So the whole point of what we're doing today is making sure that we're able to have two factors here that end up multiplying to zero. And if two things multiply to zero, at least one of them must be zero. So we're going to end up writing 5x minus 8 equals 0 and x plus 8 equals 0. So one of these two things must be true. So 5x equals 8. We just added 8 to both sides of the equation there. We're going to subtract 8 on this problem. This one we get x equals negative 8. On this one here, we still haven't solved for x. We got to divide both sides by 5. And therefore x equals 8/5. And we have x equals negative 8. Beautiful. Continuing right on. On this one, same exact idea. So here we actually have three equations. One of them is actually kind of worthless, so we're going to talk about one of them in just a moment. The reason why this one on the far left is worthless is because 3 does not equal 0. So this one out here by itself kind of doesn't even matter. You really didn't even need to write it, but it definitely doesn't equal 0, so it's not relevant. Then we're going to add 6 to both sides, kind of just like a regular old equation. And honestly, you don't even need to show that work. You know, if you're moving the 3 over, it's obviously like a plus 3. You're dividing both sides by 4. It is obviously a division by 4. You don't need to show that work. However, if you want to show that work, I'm not going to tell you no. Continuing on to number 3. So this one I actually took from a previous question and simply added on the equal 0 to it. What are the things that multiply to 21? Well, 1 times 21 and 3 times 7. They are both positive, so these are both positive. These add to 22. These add to 10, and therefore that's the one we want. Matches with the 10. So we got x plus 3 times x plus 7 is equal to 0, and therefore x plus 3 equals 0, and x plus 7 equals 0. And some people might be saying, Mr. Richards, couldn't I just jump to x equal negative 3 way up there? Definitely. Can I just jump to x equal negative 7 way up there? Definitely. Heck, you could do it from up here if you wanted to. I am more than happy with you if you do that. Now, number 4 is not quite set up for us yet because we have not got it to equal 0. You can only use the zero product property, the ZPP, if one side equals 0. So we need to start by subtracting 3 on both sides. That is to say we got to get rid of this on that side. We need to make this a squared plus a minus 6 is equal to 0. And now it equals 0, so we can factor. So we have our negative 6, which means we have 1 times 6 and 2 times 3. Adds up to a positive though, so that means the bigger number is positive, the smaller number is negative. So this is the one that ends up working because it adds to 1. So it's going to be a minus 2 multiplied by a plus 3 equals 0. A minus 2 equals 0. A plus 3 equals 0. A is equal to 2. Beautiful. A is equal to negative 3. Wonderful. Let's continue moving. Number 5. Same ideas as always. We're going to go ahead and take that negative 7n, move it to the other side of the equation. When you do that, it becomes positive. So n squared plus 7n is equal to 0 now. And this is the monomial factoring, the nice and easy one where you just have n times n plus 7 is equal to 0. And therefore n equals 0 and n plus 7 equals 0. So n equals negative 7, subtracting 7 on both sides there. Easy enough. All right, same ideas as this one. We have to take that 6r and we need to add it to both sides of the equation, add it to the right place so that we still end up equaling 0 in the end. You could write minus 1r if it makes you happy. You got to figure out the stuff that multiplies to 56. Now, if you're able to figure out in your head right away, oh yeah, it's got to be 7 and 8, then more props to you and you can just jump right into the factoring. But if you can't, remember to write down all the different guys that work out. 2 times 28 here. We got 4 multiplied by 14, and then we have 7 multiplied by 8, and those are all the possibilities. This is a negative here, so the bigger number gets the negative, but like I said before, it's definitely just going to be 7 and 8. That's what adds to negative 1 there. So we get r plus 7 multiplied by r minus 8 is equal to 0. R plus 7 equals 0. R minus 8 equals 0. Holy moly, subtract 7 on both sides. Here, I'll show the work on this one, just to make you happy. Maybe it doesn't make you happy. I have no idea. And there we go. Easy enough. We're all done with our very first one here. And I just noticed the bottom of my screen is kind of cutting my mouth off. Sorry about that if it bugged anyone. I don't think it should have, but you never know. Let's go on to the next page. Number 7. We have this this guy here. Maybe I need to focus the camera. Didn't help. I think it just printed poorly and it's looking a little blurry on the printing. But the same exact idea, we need to move everything to one side. So we're going to go ahead and add that 7x squared to both sides of the equation. Make sure you add it to the correct spot. And then you get positive 1x squared, so we don't need to write the 1. The numbers that multiply to 24 and add to negative 2. I'm not going to show the work on this one because I think you can do it. X plus 4 and x minus 6 is equal to 0. Because, you know, those are the numbers that add to negative 2. You're adding to this guy, multiplying to this guy, and skipping even more steps for you. X equals negative 4, x equals 6. This is like, you know, starting to get to that bare minimum level of what you can be doing. You know, if you want to show even less, you can. After that, this 2a needs to move to the other side here. So we're going to get a squared minus 2a minus 48 is equal to 0. Now, continuing on, same exact idea. Sorry, I just had a brain freeze right there. I was hearing things downstairs. My mom is having a bunko party downstairs right now. Let me tell you, not for me. Not for me. There are many people downstairs saying many words. That is not for me. No, I'm just not into that kind of thing. I'm into these numbers and Pokemon. Here we go. We got a plus 6. We got a minus 8 equal to 0. A plus 6 equals 0. A minus 8 equals 0. So a is equal to negative 6 and a is equal to positive 8. There we go. We are continuing on. I got distracted by my phone. 1 second. I gotta pause this actually. Yeah, you see, my girlfriend was a smart one. She just left completely and has been studying at, you know, at ASU all day instead of coming home to avoid the commotion. Smarter than me. That's all I gotta say. I'm here with the commotion. Anyways, let's continue on here. I'm gonna fix my camera. I feel like it's pointing too high up now that I looked at it. Okay. I'm happier with that, I suppose. Breathe. Peace. Inner peace. Let's go. All right. Factor out an 8 here because we have an 8 that's out in front. K squared plus 2k minus 8. Again, the idea there is anytime all three of these guys can be divided by 8, we're just doing our division by 8, division by 8, division by 8. You know, that's where each one of these numbers is coming from. The 1, the 2, and the negative 8. And then continuing on, we're factoring just like normal the numbers that multiply to negative 8. 1 times 8, we got 2 times 4. Bigger number is on the right, that positive guy. So we end up with this one because this one adds to 2. So k minus 2, k plus 4 equals 0. And therefore k minus 2 equals 0, k plus 4 equals 0, and k is equal to 2, and k is equal to negative 4. Keeping the ball rolling, let's do it. So we're going to go ahead and subtract a both sides. Wonderful. 2a squared plus 6a minus 36 equal to 0. Same concept as number 9. We're going to factor out that 2 out in front. So 2a squared plus 3a minus 12 is equal to 0. Oh, minus 12, minus 24, minus 18. I'm sorry. This is what parties do to my brain. They make me panic and I get math problems wrong. End of the world. What numbers multiply to 18 and add to 3? That's going to be a plus 6 times a minus 3, and that's going to equal 0. And therefore, a plus 6 equals 0, a minus 3 equals 0, a is equal to negative 6, a is equal to positive 3. Kaboom, kablam. We're moving on, number 11. I wonder if this is the last page. Did I make it one more page? Oh man, look at me being mean. There's 2 more. We got 6 more questions to do. Let's do it. So, same ideas. Subtract that 12n on both sides. Here we go. And when we do that, it's kind of like moving it, you know, right here. So we got 3n squared minus 12n plus 9 equals 0. All 3 of those are divisible by 3. Now, some of you might start noticing, hey, I saw that question on the board. Well, the deal is there's only really so many factoring questions you can give. So a lot of them end up being repeats, which means that you kind of just memorize the answers in a lot of questions. Anyways, this is a really easy one because only one thing's multiplied to 3, 1 times 3, so it has to be 1 and 3, and they're both negative because it adds to a negative. Minus 3 equals 0, and minus 1 equals 0, so n is equal to 3, and n is equal to 1. All right, keeping it moving. This time we have a whole lot of different terms. You got to move all of them over to the left. No big deal. We're just going to add 8 to both sides. We're going to subtract 2x squared on both sides. Make sure you line them up correctly. And we're going to add 4x to both sides. Didn't really matter which side we moved to, but I kind of like keeping this guy positive out in front when we can. So that's going to give us 7x squared plus 28x and minus 84 equals 0. I believe all of those are divisible by 7, so we're going to factor out a 7x squared plus 4x, and then that divided by 7 would be 10, 11, 12 equals 0. The numbers that multiply to negative 12 and add to positive 4 are going to be x plus 6 and x minus 2, which means we have x plus 6 equals 0, x minus 2 equals 0, x is negative 6, and x is positive 2. There we go. We're done with that one. Number 13. Now we get to that factor by grouping that so many people just really detest and hate and wish did not exist, and they're not even wrong. All right, so we have 2 times 5 here to start. So 2 times negative 5 is equal to negative 10. We got to figure the numbers that multiply to negative 10, add to positive 3. Well, 1 times 10 and 2 times 5 are the only things that work. It's a positive, so the number negatives are on the left. There we go. There are the numbers that add to our positive 3. So we're splitting this guy up. 2k squared minus 2k plus 5k minus 5 equal to 0. So again, copying there, splitting this into 2. Divide down the center. 2k, k minus 1 plus 5, k minus 1, that monomial factoring idea. K minus 1 comes out. 2k plus 5 comes out, and k minus 1 equals 0, 2k plus 5 equals 0, k equal to negative 1. We're running out of room on the screen here. 2k subtracting 5 on both sides, dividing both sides by 2, and k is negative 5 over 2, or negative 1. They're my two solutions. Moving along to number 14. This one, man, I'm looking at it in advance, and I am regretting having this problem on here. So we got 35r squared plus 8r, and that looks like minus 16 equals 0, because we have to multiply 16 times 35, and figure out which two things multiply these two guys together. This one is 100% going to be a calculator thing, so let me get a calculator out. All right, so we're all done. Here we go. There's 35 times negative 16, and we get 35 times negative 16 on the calculator. And if you do it on the calculator, you get 560, and then you have to list off all the things that add to 560. Now, let me tell you a cute little thing that you could do anytime. Let's say you have that really tough homework assignment. You know how to do the question. You showed all your work on this problem. You know how to do it. And then your teacher gives you this 560 and you're like, what the heck, Mr. Richards? Why would you assign this problem? Or maybe you have a college professor and this is actually a homework assignment that you really got to get done and it's worth points and you have to finish it. What are you going to do? So there's this website, Wolfram Alpha. You type in the word factor and it will factor it for you. So it will look like you did the work, because it gives you all the factoring right there. Actually, you can't see what's on my screen, can you? Now you can. Okay, there's this website called Wolfram Alpha. It's beautiful here. It does the factoring for you. So I typed this in here, did the factoring for me, so I don't need to go through all the different steps to get to the answer. Now I will, just to show you the work for it, but you do not need to. So FYI, don't need to. Letting you know right now. Boom. It's there. All right. So let's move on. Doing the actual work for it here. The numbers that would end up working for you are going to be positive 28 and negative 8. Those are the two that end up working. You might have written negative 8 and positive 28. Actually, that makes more sense the way I taught it in class. So 35r squared minus 8r plus 28r minus 16 equals 0. Divide down the middle. take an r away. Oh, wait, 8 that doesn't work, does it? It doesn't work at all. Right, yes it does. 28 and 8 add to 20, not to 18. What am I saying? I literally just had a calculator do it for me, and my brain is not functional. Embarrassing, guys. Embarrassing. I have no idea what just happened. So, I apologize. 28 and 8 obviously do not work, but what does work instead is going to be 20 times 28. So I don't know exactly why I am failing in my brain right now, but those are the two numbers. I apologize, everyone. This is what happens. I got too nervous today, and anxiety kicks in, and this is why I understand and let people, you know, have their days off when they need them. So anyways, we divide by 5r here, we get 7r minus 4, and we divide by 4 here. On these two, 4, we're going to get 7r minus 4 again, and that's going to give us 7r minus 4 multiplied by 5r plus 4 equal to 0. We got 7r minus 4 equals 0, and 5r plus 4 equals 0. 7r equals 4. Divide both sides by 7. R is equal to 4 over 7. Subtract 4 on both sides. 5r equals negative 4. Divide both sides by 5. And we get r is equal to negative 4 over 5. And here are our two beautiful solutions. Took us a little bit of time to get there. Let's do it. Last two problems. Pump them out. Here we go. So we got 6x squared plus 29x minus 35. So again, add 35 to both sides. Kaboom, kaboom. We're actually just going to do all the work on this one. No cheating, no calculators. That'll probably just make it easier for me anyways, just to not have to freak out. So we're going to start by multiplying these edges. 6 times 35, and that's going to give us 210. We need to figure out the numbers that multiply to 210, but add the positive 29. So we can just start going. 1 times 210, 2 times 105, 3 multiplied by 70. Does 4 work? No. Does 5 work? Yes. 5, and you're multiplying it by 2042. Does 6 work? I believe 6 does work. So 6 multiplied by what? By 30, 35. Not quite. That's of a difference of 29, but not quite. We want them to add the 29. So 8 will not work. 7 already does work. So 7 multiplied by, what's it going to be? It's going to be 7 times 30. So we're getting closer. Adds a 27. This had to 41. There's a 37. We're getting closer. 8 will not work. 9. Does 9 work? 180, 30. Nope, 9 does not work. How about 10? 10 definitely does. 10 times 21, even closer to the correct answer. Does 11 work? No, 11 does not work. How about 12? 12 won't work because 4 didn't work. 13. Don't believe 13 works. 14. 14's probably got to be the answer. 14 multiplied by 15. Yeah, that's going to be it. 14 multiplied by 15 took us all the way down to the bottom. These guys added to 29. We finally found the answer. But again, hey, you could have used that Wolfram Alpha just like I suggested. There is all the work for it. 15x plus 29 equals 0. Down the middle, factor these out. You get a 2x, be a 3x plus 7. These two guys, wait. Oh, this should have been a 35. I wrote 29. What a disaster. How come no one told me? I'm sure someone did. That should have been 35. Anyways, these guys factor out a 5, and that'll give us 3x plus a 7. 3x plus 7 times 2x plus 5 equal to 0. So 3x plus 7 equals 0. 2x plus 5 equals 0. Subtract 7. Subtract 7, 3x equal negative 7, or x equal negative 7 over 3. Subtract 5 on both sides, 2x equal negative 5. Divide both sides by 2, x is equal to negative 5 over 2. Easy enough. Number 16, last one. Hopefully it's not pain and suffering. So we got to move everything to the left again. Subtract 2p, subtract 8, subtract 2p, subtract 8. Here we go. 3p squared plus 13p plus 4 is equal to 0. So again, we got to multiply the 3 times 4. 3 times 4 gives us 12. We got to figure out numbers that multiply to 12, add to 13, but hey, it's easy right away. 1 times 12 goes to 13, doesn't multiply to 13, equal 13, but it adds 13, which is what matters. So 3p squared plus 1p plus 12p plus 4 equal to 0. Factor out a p, 3p plus 1. Factor out a 4, 3p plus 1. 3p plus 1 times p plus 4 equals 0. 3p plus 1 equals 0. P plus 4 equals 0. 3p equal negative 1. Divide by 3. P equal negative 1 over 3. Subtract 4 on both sides, and we get p equal to negative 4, and we are done with this assignment. It took us 21 minutes. Not that big a deal. Peace out, everyone, and enjoy. Have a great rest of your night.